I don't know for people who, um, I'm not sure how widely this is used in the community. At least on edX.org, we have thousands of these. We have as many of these as we have courses. Um, course reruns to copy entire course runs content. We have LMS. The LMS can be an LTI, consumer, and a provider. And CCX is a less well-known feature, custom courses for edX, that enables modifications for private runs of courses, where you can override things like grading policy, due dates, visibility modifications, but it doesn't come with studio access. Then there's the import-export mechanism. Some course teams use this for actually like doing their authoring. And like do all their work in Git and push things up. Some people just use import and export to get a dump of a file, change a whole bunch of stuff all at once, and then import it into a new course. And we do have this sense of licensing tracked at the for Creative Commons. I believe there are like maybe 3 or 4 licenses that we allow, and that's tracked at the course level, although we don't do a whole lot with that today. Okay, so why do we need something new? Why not just extend module store some more and add another layer of it? So we want content that's unbound from courses. Our Lab Exchange wants short sequences of content. Courses, also, like I said earlier, the current course hierarchy that we have is the navigational hierarchy of chapter and subsection. That is basically what it is because that is what 6002 required. The first course required. It was a 16-week-long electrical engineering course. But depending on your course needs, like that might be overkill. That might not be enough. We have courses that have single chapters that have single sequences in them because it's because it's not really meant for that kind of navigation. Con-style knowledge maps are sort of an aspiration. There are adaptive use cases. Harvard has put in some heroic efforts to get adaptive to work on the edX platform. And then there are also, this desire to have promotional pieces where you can give like a preview of a course, sort of isolate it and put it in line in like a marketing page. Also, there's a desire for better lifecycle tracking for things that are already shared. So, for instance, video is kind of in this weird place right now because we've got Val, which is something that was meant for a video team in order to manage video centrally. And so there's a layer of indirection between the courses, like, video and the sort of centralized video library that Val represents. However, permissions get very strange in this scenario, right? Because, ownership is sort of at the course level for a lot of edX platform assumptions. And if you have a video that is used by 5 different courses and do they get to upload changes to the subtitles, like it doesn't really mesh well. Like edX platform is solely about sort of course level ownership of things, and other sort of tracking lifecycle of other content, of borrowed content, is not really built into the platform well. Okay, so I just said that we don't have all our content is bound to courses, but we have content libraries, which might be a contradiction, except it's not, because content libraries are just courses. Content libraries are very primitive courses that only have one vertical in them, but essentially we reused a lot of the existing infrastructure that was already built for course in order to make the Studio UI easier to build and publishing flow easier to make in a hurry. But it carries with it a lot of baggage and complexity, and sort of really limits us into what content libraries can do today. So, because honestly, dynamic content today on the edX platform is kind of a hack. The course structure is static. It's always exactly what it is in the beginning. It's the same for everyone. Every possible permutation of that course is encoded and retrieved, and then content is selectively hidden from a user at the time of render through a bunch of access checks. Right, so that means, next part. So that means when you have a split test module and you have option A and option B, both option A and option B are in that sequence, and the access checks, give you one or the other. And that means when you have a randomized problem inside a sequence, a copy of the entire content library that randomized problem came from is copied into your sequence, and your access check determines whether you can or can't see the one particular problem that you have. So, this makes it really hard to scale. Like, we can't do large problem banks with tagging. If we had 1,000 problems in a problem bank, which is not, which is a totally valid use case. There exists problem banks with thousands of problems in them. But we can't bring them over in a straightforward fashion, because if you ever used one for a randomized problem, it would have to inject 1,000 problems into your sequence, and that would just kill your performance. I mean, it's already, even the people who already use problem banks as they exist today, like, do suffer performance issues when they start to use it very aggressively in their courses. Adaptive, like true adaptive stuff, is also really hard to do in this scenario, because the content ordering is fixed, and so you can't. It's not a practical problem. It's not practical. It's not tractable to encode every possible permutation that anybody could possibly see into this gigantic sequence, and then pick subsets of it at each unit level. So when Harvard did they wrote a paper about this, that when they did their adaptive system, it is this heroic effort where they had like edX as an LTI, like they had chained LTI basically. They had an ATI a sequence that opened an LTI consumer that talked to their own adaptive engine, which then opened another, like used edX as an LTI provider to give individual problems, and actually made use of an access bug in our, an access check bug that allows you to directly access A/B contents in A/B tests that you are not actually a part of if you go to the leaf node. So basically, it is fragile. Like, we applaud their efforts, and it is awesome that they got it to work, but the platform needs to support it better than that. Also, it's difficult to track a problem video or sequence across reruns. Like, a lot of times there's just absolute copying, and you don't know, for instance, it's hard to tell, like, how well used is this problem? How much do people, how do people do on it? How much value do people find in it? Next. And yep, okay, and that's the end of my part. So now that I've laid out like all the horrible things that exist today, Braden's going to talk about the wonderful things that will exist tomorrow.
So what we're trying to build with Blockstore will be an example of a learning object repository, because it will store learning objects. So that gives us access to a lot of prior art for learning object repositories that are out there. And oops, spoiling it there. In theory, there should be lots of great examples that we can look to, and learning object repositories often market themselves as these beautiful palaces of content where course authors and educators can wander the aisles and find the most amazing content and pick and choose it, and talk to the community of educators and improve content together, and then mix and match content and build these amazing courses using the content. Unfortunately, in practice, there haven't been a lot of learning object repositories that really succeed to that level. Examples are hard to find, and when you do find them, they're often either really simple so that there's not a lot of value to them, or they're so incredibly complex that they have very little uptake. Many lack critical mass. There's not a lot of content, or not enough people using them and sharing the content. or their capabilities for reuse are more limited than you might think. There's also a lot of just abandoned learning object repositories out there where someone got a grant and they created something as an academic project or something like that, but then the funding dried up and no one was able to continue the work. And then there's also the issue of unclear licensing. If people use idiosyncratic licenses for their content, then it's hard for any given educator to know what they can and cannot use in their course or their learning context. So given all that, as we're thinking about Blockstore and how we build it, we're trying to focus on use cases where we know there is significant need in the Open edX community. Specifically, those are things like the randomized problem banks that Dave was talking about. We want to add support for tagging and huge problem banks and avoid the scalability issues that exist today. We know that there's huge demand for adaptive learning, so we want to be able to support huge databases of content that machine learning algorithms or whatever can draw from and add and show to users dynamically. We know for Lab Exchange, for example, instead of having these full rigid course structures, we want to have smaller sequences of learnable content where you can work through the equivalent of just a few units, and that's your learning experience. We also know that one example of reuse that we do see in Open edX is course reruns, where you rerun a whole course with some modifications, so we want to support that well. Also MIT's CCX use case, which is also used by a few other people, where you have one master template course and then individual educators create a clone of the course with their own little modifications and then run that to a group of students. And then of course, import and export enables a lot of things. So these are examples of the use cases that we're trying to optimize Blockstore for. We know that people want these, and if we can build something that satisfies these well, we feel that we'll get really good, we'll build something really useful. So what is the design actually like for this thing? First of all, we're tackling a problem that has a lot of history here and trying to build a replacement for several things at once. So Blockstore is only part of, Blockstore technically is only part of the solution to some of the problems that we mentioned. For example, the current module store that stores content is very tightly integrated with the XBlock runtime. And we want to separate that out so that the XBlock runtime either runs in the LMS and is separate from Blockstore, or eventually is completely separate on its own from both the LMS and Blockstore. There's a lot of technical debt. For example, X modules have been theoretically kind of deprecated for a while in favor of XBlocks, but there's still lots of X modules in the edX platform. So we're hoping to use Blockstore as a big stick to kind of force us to migrate those to XBlocks, so we only have to support one type of content for now instead of two. And then right now, the way that XBlocks and XModules store static assets is a little bit messy and also pretty closely coupled with the rest of the system. So we want to find a way to clean that up. And that's part of what we're doing with Blockstore. So for Blockstore specifically, its high-level responsibilities, we want it to store content and version history, as well as, and when I say content, that also means static assets like images and videos and PDFs and whatever else authors use in their course. We want it to track and enforce content ownership and permissions and licensing as first-class principles. So whatever types of content you store in Blockstore, we always want to be able to tell you who created this, who's using it, what license is it under. Usually that might be all rights reserved, but it could also be a Creative Commons license, in which case we'll want to support reuse. And we want to make Blockstore a little bit of a platform that you can add extension points to. We have lots of cool ideas for what this might look like. But as part of that, it means that we need to have lifecycle event notifications. So whenever someone adds content or modifies content or deletes content in Blockstore, that will create these events, which can then be consumed by other web plugins or by other apps in the ecosystem. And that should enable lots of cool functionality. So Blockstore is built around a few key concepts, and one of those is this concept of a bundle. A bundle is simply a versioned group of files and metadata. So you have, it's kind of like a small folder. It has a bunch of files in it. You can make changes to the files and create a new version. And we store metadata about it. As we've designed it, the contents of a specific version of a bundle are immutable. So every time you make any changes to a bundle, that creates a new version of the bundle. A typical example of a bundle might be a problem in a problem library. So if you have a content library and you have 1,000 problems in it, each of those problems could be a bundle, and that bundle would have one OLX file, which defines, say, the kappa problem, and then it might have some images that are used in the kappa problem. So together that would comprise one bundle, and it would be versioned. And yeah, the metadata about a bundle version is mutable. So you can apply tags to a bundle without changing the content of the bundle, for example. And the architecture that we're going with for Blockstore uses a file system metaphor and actually Amazon's S3 file system or similar file system service to actually store content and represent the content itself. It also stores the metadata in MySQL, like we do for most things in OpenEdX. So why are we doing a file-based system for Blockstore? For one thing, files are a pretty good metaphor and abstraction. Everyone is familiar with them. Unix saw fit to put everything as a file. We're not quite doing everything as a file, but it allows you to understand things very easily using something that we're all familiar with. And in many ways, this lets Blockstore be simpler. For example, Blockstore doesn't need to know about XBlock runtimes and how they work if all it needs to understand is what an OLX file is and that it can store a bunch of OLX files in bundles and make those available to an XBlock runtime. Another example is internationalization. Today in OpenEdX, if you want to have a course in 2 or 3 languages, you have to create 2 separate courses, and there's no way to link them. So users have to enroll either in the English course or the French course. You can't switch languages halfway through and see the content in the new language. With Blockstore, we might be able to do something much better because given that it only is aware of files and you just have course content represented as OLX files, you could just have an OLX file and then like a .fr.olx file next to it, which has the French translation of that OLX file. So Blockstore wouldn't even have to be aware of it, but then the LMS could request the French OLX file instead of the English OLX file, and your course could be bilingual where available. And yeah, as you guys are talking about in the comments, it won't use MongoDB at all. It will just use MySQL and S3 or some other content store if you don't want to use S3. Another reason that we're using files is that often the lines between what is an XBlock and what comprise that XBlock are kind of blurry. For example, the HTML X module today is mostly just a wrapper around an HTML file. And if you export a course into a tarball and open it up, you'll see that it really is just an HTML file and then a tiny little OLX file that references the HTML file. Or the video X module will have a ton of source files for the video in different encodings and subtitle files and so on. So for some XBlocks, especially video, there's actually a lot more files that comprise the content than there is just a little OLX bit. This also allows us great flexibility. For example, if you want to store PDFs as content, or maybe in the future even other things besides OLX or XBlocks, Blockstore can handle it, and it's kind of future-proof because it can store any type of content that you can represent as a file. Also, by storing everything on S3, it's pretty cheap to scale and should perform really well. Question in the chat is, does this mean that Blockstore will have Django model representations? The metadata does have Django model representations and is stored in MySQL, but the actual content itself does not. It's stored on S3, as OLX files or whatever. So there's no Django model for the actual content itself. So how does Blockstore relate to XBlocks? Today, XBlocks are stored in two different ways. When you store them in Module Store and import them or create them in Studio, they're serialized in a JSON format and stored in Mongo's JSONB format. And then if you export them to a tarball, they're serialized as XML or OLX. So what we want to do for Blockstore is focus on the Studio case, the representing XBlocks as XML or OLX. And so Blockstore will store XML or OLX serialized XBlocks. Blockstore itself won't understand what XBlocks are. So it doesn't have XBlock runtimes. It can't parse an OLX file and tell you what blocks are inside it. And we're still deciding about this. We might have some functionality in Blockstore like X-include so that it can combine multiple XML files into one and let you do cool things with content reuse that way. But that's still to be decided. And another, because we're using a file-based system, we can store any arbitrary content and not just XML or OLX. So for example, if you have Python libraries, which MIT uses with their XBlocks, or you have precursor files, like you have a whole bunch of LaTeX files or something that compiles to OLX, or you have a Word document that's the source for the PDF document, and you make only the PDF available to students, you can put all those precursor files in Blockstore as well. And then it should be a lot easier for your content authoring teams to track where the source files are and to edit those. Another long-term goal of Blockstore is to move away from using XBlocks for container types. So what that means is in the Open edX platform today, the course itself is an XBlock, and each subsection and subsection and unit in the course are also XBlocks. A content library is also an XBlock. And for example, the unit XBlock has a bunch of JavaScript and UI that implements part of the LMS features. But if you embed that unit on another site, then that JavaScript doesn't really work properly. And it's kind of a confusing architecture in some ways. So what we'd like to do is move away from using XBlocks for structural parts of the course and just use XBlocks for leaf nodes and store those XBlocks in Blockstore and store the course structure in Blockstore in some other format that's not XBlocks. We're still figuring out exactly what that will look like, but we feel there will be a lot of advantages to moving away from the everything is an XBlock model and focusing on XBlocks are the content that you learn. Another core concept of Blockstore is the collection. So your content is in bundles, and every bundle is part of a collection. A collection is where we attribute authorship, ownership, and licensing, and all the other metadata that gets shared by all the content that a particular organization has for a particular purpose. So collections will just define permissions, ownership, licensing, all that stuff. An example of what that might be could be a problem bank. So the physics department might have a physics problem bank which has 10,000 problems which are all tagged for learning objective and difficulty level. And then anyone who wants to make a physics course can pull in content as they need and search for, I need a hard physics problem about Newtonian gravity or whatever it is that they want. Another use case for a collection might be holding all of the runs of a course. And then the third architectural piece of Blockstore, in addition to bundles and collections, are links. So links are like symlinks in a file system. If you have a collection and bundles where you're building a course and you want to use some content from someone else's collection, you can basically build a symlink into your course for their content. And links always point to a specific version. So if you're building a course and you want to use someone else's problem in your course, you can link it into your course, and then it will sort of freeze it at that particular version. In the future, if you come back to your course and they've updated the problem upstream, you can choose if you want to update it to the newest version or not, just like you do today with content libraries. Except unlike how it works today, this is based on essentially a symlink and not fully copying the content into your course. And the way the architecture works is if you have a link to some problem, for example, and you want to use a newer version of the problem, you will bump to the newest version of that, and that will create a new version of your bundle where you're using the problem. And we don't allow link cycles, so you can't link to a problem which then links back to your course for obvious reasons, hopefully. So a disclaimer is we're still figuring out the data modeling and what this is going to look like, how to optimize it for the use cases that we know course authors will have. We know that they have today and the things that they'll want for tomorrow. But in terms of what we're thinking at the moment, we are designing Blockstore to be write optimized and not read optimized. And that means that when, for example, you go into Studio and you're working on editing course content and creating courses, then you'll be working directly with Blockstore, and it will be really optimized for that use case. Reusing, linking, searching for content, editing, publishing new versions, that sort of thing. But when you hear all these links and XML serialization and stuff, that might sound inefficient for serving a scalable LMS where you might have tens of thousands of students using a course. So what we're planning to do is for the LMS, there will be some sort of read optimized version of each course that gets compiled out of Blockstore, which the LMS uses. One of the limitations of Module Store today is that it's used for both reading and writing, and it's not particularly optimized for either one. So with Blockstore, we want to optimize for writing and have a separate thing, like maybe the existing, what's it called, the course blocks API that can store an optimized version for the LMS to read from. We're figuring out the granularity of a bundle, whether a bundle is just the smallest possible thing, such as an individual problem or video, or whether it can be units and sequences. But it does seem like there is a desire to reuse things at different levels, to reuse just individual problems, or to reuse a unit, or to reuse a whole sequence together. So we're still figuring out the ideal way to represent different granularities of content in bundles and how that plays into linking bundles to new contexts. Something that I'm really personally excited about is the fact that with Blockstore, we can group static assets into the bundle right where they're used. So if you have a problem, you can have any images that are needed by that problem or any PDFs that are referenced by that problem right in the same bundle with that problem. That's as opposed to the situation today where your course has a big static files collection on the files and uploads page in Studio, where you might have hundreds of different assets, but you can't really tell where in the course they're being used. And I've seen the files and uploads pages for some big courses, and it's kind of scary in there where there's lots of like similarly named PDFs, and it's very hard to tell what's the newest version and what's used where, and if it's okay to delete this file or not. So I'm really hoping that associating static assets directly with individual blocks and units where they're needed will clean that up a lot. I see a question from Nate if this will support nested folders of static assets. At the very least, you will be able to support static assets with individual blocks in the same bundle as that block, and then static assets at the unit level or at the subsection level or at the course level. So if your asset is going to be used throughout the course, you could put it at the course level. But we probably will just allow arbitrary folder structures for static assets. So if you want to group them into whatever folders and tree structure you want, you'll be able to do that. We're still figuring that out, but I don't see why we wouldn't support some level of organization of assets. And here is an example of what you might see in a bundle, a sequence.xml file containing the OLX, a units folder containing each unit as an OLX file, and then a static folder where there's some static assets. And finally, if you want to see the design doc, there's a few versions of it. I think this links to the latest version where we hashed out the early ideas for Blockstore. You can click on this link or copy it down because I can't click on the video. If you want to see the repository where we have the code, which we're working on every day, you can go to github.com/open-craft/Blockstore. And if you want to contact us, there's our email addresses. We'll move to questions now. Any other questions for David? Question from Rowan. All the metadata for analytics will be in MySQL. In terms of the content, yes, all the metadata about Blockstore will be in MySQL. So if you want to know, where is my content being used, how many courses use this particular problem from my problem bank, all that data would be in MySQL. Another question, will any other backends besides S3 be tested? Well, certainly on DevStack, we just use the normal Django storage, which stores on a file system, and which would support single server use cases. So if anyone's deploying OpenEdX to a single server, they could use the file backend if they wanted. In terms of Azure, Google Cloud Platform, etc., we don't have any plans to test those. Would love someone from the community to be involved in something like that. But yeah, for our own purposes and what we're building so far, we only have plans to build for S3. But we'll use standard Django file storage mechanisms as much as possible. So it should be easy to plug in other backends. Follow-up question from Rowan. If I want to count how many videos are in a particular course, will I be able to do that with the metadata in MySQL? That depends on the exact data model that we end up with. It's possible that that would only be in the sort of course outline file, which lays out the structure of the course, in which case you would need some other Blockstore API or query it from the read optimized version that comes out. So I'm not totally sure. It may end up that we stick to requiring each XBlock to be in one bundle, and if we do, and you can tell the type of the bundle from MySQL, then maybe you could. So I'm not totally sure about that one yet.
Yeah, I mean, I think with the current data model, it's actually the cheapest and fastest way to do it would be to examine the actual the file where we would put like the course structure, like the bundle that. Sorry, I think the fastest way to do it in the current data model would be to find the course file in the bundle for that holds the structure of the course and to examine that. But again, like Brandon said, these things are shifting around a lot. Well, I'll write that down as a use case, certainly. But yeah, that's.
One thing that I would add is that I actually am very glad that we are separating the edits aspect and the storage, optimizing for writes versus optimizing for reads. And so for this particular use case, I mean, I think if we can satisfy that on the optimized read side of it, then we really can, have a command query responsibility separation design pattern and not worry about having Blockstore's data model necessarily support this type of querying. So just anyway.
Yeah, well, I mean, I feel like it's interesting that a lot of times when we talk about sort of optimization for read, one of the things we're talking about is not requiring many round trips in order to render you the particular thing that you as a student want to see. So, all the stuff that Nimisha, that you've done with block transformers and getting, mapping out the inheritance tree and flattening out the inheritance tree and all that. But I could definitely see something like this case in particular be used like in the authoring sense, like you as an author might care, like, there are sort of aggregate statistics about your course that you might care about, like authoring before it ever hits users, in which case I think the data model of Blockstore needs to be able to support some of those types of queries. And also, one other thing I want to say about the data model is there's definitely a separation between sort of read-write versus read-optimized as the LMS. But I think there's also a kind of separate optimization that we need to make between data that is optimized for reuse is kind of different from data optimized specifically for authoring. Right? So for instance, you might, as an author or as an authoring system, think of things in terms of units and moving things around and like files. However, if you are reusing a piece of content, one of the things you really care about is sort of stable IDs, right? You want to make sure that if someone moves, like we give you this freeform video, if we give you a freeform bundle and you can stick the video anywhere you want, and one day you decide to move the video from this unit file to this other unit file, then whoever's reusing that video will want to be able to have some stable reference to it. So yeah, I think it's becoming more and more apparent as we flesh through the design that just optimization for authoring and optimization for reuse are actually also like two different things in addition to the read optimization of the LMS.
Yeah, and I think so. In addition to those three, a fourth one may be data optimized for reporting and administrative, right? And so I think, for instance, like, yeah, I mean, so this is a conversation in terms of data analysis about your course, right? How much of that do we think needs to be at the authoring side versus it's more of data analysis? And although the data analysis could be rendered both for authors as well as for learners, as well as for administrators as well, but yeah.
Yeah, and I think one of the hopes that we have in the system is that it's modular enough that you can hook into lifecycle events, that you can be able to generate those statistics asynchronously if need be, in order to, like, if you have metadata that you need to gather about any particular thing, that you can build it in a fairly pluggable way. At least that's the hope. Yeah, I think sorry, answering the question, can the presentation be shared? I believe that's the intent. I'm not sure if we've fully figured out if we got past our initial technical difficulties. I don't have permission to record, so.
Yeah, we do have a recording of this. I will update this on the wiki page for this OpenEdX Hangout, where we'll include a recording of this. Unfortunately, I think we started maybe like 5 minutes into when the presentation started, but it was while Dave was still talking about all today's problems. So,
all right.
and way before what our future is holds for us. So so hopefully that will be good. Yeah. Oh, and the slides is what Julio's also asking about, Dave and Braden.
Oh, yeah, can definitely share the slides. Can do that right now.
So we have about 4 minutes left. Are there any final questions or thoughts about even just the architecture Hangout in general? Any thoughts about what we might want to talk about next time?
I'll just mention that as part of the work on Blockstore so far, we also have a prototype of tagging service. So you can define taxonomies of tags and then apply them to content. And then you can search for content based on those tags. We're still implementing the search part, but we've got some early prototypes of tagging built up, and I'm really excited about that.
Okay, well, thank you very much, Braden and Dave, for taking this time. So it's great to have a preliminary, perspective and view, and also just the design mindset and thoughts that you guys are having early on while you're working on this. So that's been great. I will send out another survey like we did last time. So feel free for people who are able to listen either synchronously or asynchronously if you hear the recording, and provide your comments on just the format of the Hangout and so forth, as well as the content. And then, yeah, asynchronously, feel free to provide suggestions for what we want to talk about next month. So.
And if you're interested in Blockstore, follow the repo on GitHub and feel free to participate in discussions on the pull requests and issues there, as well as on the wiki page for the design. We'd love to have more input.
Okay. Sounds good, everyone. Thanks so much. You get 2 minutes back.
Take care, folks.
Thank you.
Thanks, everyone. Bye.
Take care.